Before getting to polynomials, suppose I tell you that x equals 2. Try evaluating this expression, 5x cubed minus 7/4 x squared. Right, so when x equals 2, this equals 33. Now this expression, 5x cubed minus 7/4 x squared, is an example of a polynomial. A polynomial is an expression where the variables, like the x here, are raised to non-negative integer powers. So that means the exponents for the variables can be 0, 1, 2, 3, 4, and so on. They're whole numbers, like the 2 and the 3 here, and they're not negative. And these powers are multiplied by coefficients, like 5 or negative 7/4, and then added together. So next, take a look at these expressions down here. Which of these are polynomials? Remember, the variables should have exponents that are non-negative integers. Nicely done. This expression has an exponent of 3.2, which is not an integer, so this is not a polynomial. And over here, this term has a negative exponent, so this is also not a polynomial. So this expression and this expression are the two polynomials here. Now usually you won't see powers of 1 or 0 written in a polynomial like this. For example, d to the first power is just d, so we wouldn't even write this exponent. And what about d to the 0th power? What must this expression be equal to? Right, any number raised to the 0 equals 1. So 7d to the 0 is the same thing as 7. So you'll usually see first powers written without the exponent and 0th powers written with no variable. Now, the degree of a polynomial is its biggest exponent. So for this polynomial here, the degree is 6 because that's the largest exponent. So take a look at this polynomial down here. What's the degree of this polynomial? Exactly, the exponents here are 9, 7, and 4, so the degree is 9. Now here are a few names to remember. Polynomials with degree 1 are called linear. Polynomials with degree 2 are called quadratic. Degree 3 are cubic polynomials, and degree 4 are quartic polynomials. So take a look at this polynomial down here, 6k squared plus 3k minus 7. What kind of polynomial is this? Right, this polynomial has degree 2, so we call it a quadratic polynomial. Now, the leading coefficient of a polynomial is the coefficient of the highest power. So for this polynomial, the highest power is k squared, so the leading coefficient is 6. And a polynomial's constant term is the coefficient of the 0th power term, which is the term without a variable. The constant term of this polynomial is negative 7. So next, try identifying the leading coefficient and constant term for this polynomial down here. Excellent! The leading coefficient is negative 4, and the constant term is negative 2.6. Now for a trickier example. Here's the polynomial x to the 4th minus 2x. Identify the leading coefficient and constant term for this polynomial, and if you get stuck, feel free to ask for a hint. Well done, that was tricky. It might look like there's no leading coefficient here, but x to the 4th is the same thing as 1 times x to the 4th, so the leading coefficient is 1. And it also looks like there's no constant term, but that means we can add 0 here without changing the expression, so we say the constant term is 0. Now for your final challenge. Suppose I have a polynomial, and I tell you that the variable in the polynomial is x, that it's a quadratic polynomial, that the leading coefficient is 4, and that the constant term is negative 6. And I also tell you that when x equals 3, the polynomial equals 0. Can you figure out the polynomial that satisfies all these conditions? If you get stuck, click down here and we'll figure this out together. Excellent work! If the polynomial is quadratic, that means the degree is 2, and the polynomial must look like this. Some coefficient times x squared plus another coefficient times x plus a constant term. You were also told that the leading coefficient is 4 and that the constant term is negative 6. So then the tricky part was using this last statement to determine the middle coefficient. In order for this polynomial to equal 0 when x equals 3, this coefficient must be -10. And so the only polynomial that satisfies all these conditions is 4x squared minus 10x minus 6. Nicely done. To get started, try simplifying this expression by combining like terms, or click down here to review. Exactly, you can add 4x and 3x to get 7x, and adding 2y and then subtracting 8y is the same as subtracting 6y. Great, so this expression equals 7x minus 6y. Next, try simplifying this expression, 2x squared plus 5x squared. Again, you have like terms. Nicely done. So 2x squared plus 5x squared equals 7x squared. So just like this example, whenever you're adding or subtracting polynomials, the key is to combine like terms. So for example, suppose you want to add these two polynomials here, 2x to the 6th plus 3x cubed minus 4x squared, and 9x to the 5th minus 6x cubed plus 3x squared. Well, let's look for like terms, which have the same variable expressions but different coefficients. In the top polynomial, we have -4x squared, and in the bottom, we have 3x squared. Adding these like terms together, we get -x squared. Next, we have 3x cubed and -6x cubed. Adding these, we get -3x cubed, because 3 plus -6 equals -3. And that's it for like terms. There's no other term with an x to the 5th in it, just 9x to the 5th. So that's part of our answer. And the same goes for 2x to the 6th. So adding these two polynomials together, we get 2x to the 6th plus 9x to the 5th minus 3x cubed minus x squared. So let's hold on to this example over here and try another one. What's 4x to the 4th plus 5x cubed minus 5 plus x to the 4th minus 5x cubed plus 2x? Be sure your answer is simplified and you've combined all the like terms. Nicely done. So these add up to 5x to the 4th plus 2x minus 5. Notice that adding 5x cubed and subtracting 5x cubed cancel out. Next, instead of adding these two polynomials, let's see what happens if you subtract them. So if we're taking this entire polynomial and subtracting this entire polynomial, then we should put parentheses around the second polynomial. Otherwise, order of operations would mess this all up. Now, subtracting this polynomial is the same as adding -1 times this polynomial. And now we can distribute the -1 onto these three terms, which is the same as flipping all their signs. So 9x to the 5th becomes -9x to the 5th, -6x cubed becomes +6x cubed, and +3x squared becomes -3x squared. So now we're adding these two polynomials together. And here's the result. -4x squared minus 3x squared combine to make -7x squared. Adding up the x cubed terms gives us 9x cubed. And again, there's only one x to the 5th term and one x to the 6th term. So here's the answer. So when you're subtracting polynomials, remember to distribute the minus sign. Next, try subtracting these polynomials. And to be clear, you're subtracting this entire polynomial from the one above it. Excellent work! So this difference is 3x to the 4th plus 10x cubed minus 2x minus 5. So now that you've practiced adding and subtracting polynomials, get ready to multiply them in a later lesson.